Today I want to pull together with you everything we've done the last couple days and sort of see it as a big picture. Okay? So we've kind of spent 4 days, 4 parts of what we're doing. I want to talk about the polynomial that we started with. This was the first day. We did polynomial. We talked about lead coefficients and what it means when you go up down or down up or any of those combinations. That was polynomial. We also spent a day talking about factoring and factors. We spent another day talking about zeros and how the zeros show up as bounces on the graph or not bounces on the graph and how that works. And then finally, we're putting it all together with the graph. This is called the polynomial cycle, or kind of what I call it, where you can go from one to the other, from a polynomial to its factors, from its factors to its zeros, from its zeros to a graph, and from a graph you could confirm back to a polynomial. You just kind of keep going. But you know what? I could drop you into that cycle at any point. You don't have to start at the top of the cycle. You could start at the bottom. You could start at the left, and you can go backwards through the cycle. You can start with, bless you, zeros, and go back to factors. And you can go from factors, this is what your whole homework was over the weekend. You started with factors and went back to the polynomial. Or we can start at a graph and go to the zeros. We can kind of go from any part to any other part. That's what we're going to try and do today. Okay, we're going to try and start at a part and go to the other 4 and see what we can get from the other 4. Okay, what we're going to do is I'm going to drop you into the cycle right here today. I'm going to start at graphing. So, yeah.
Can we go from a graph to polynomial?
That is the one thing it's difficult to do, to go from a graph. It's possible, but it's pretty challenging. Okay, could you please graph the following on your graphing calculator? Would you take a look at y equals 6x to the third minus 19x to the second plus 16x minus 4. Now it's a cubic, so what do you expect to see? It's 3 places where it crosses, okay? What kind of shape? Like a snaky shape, okay? A snaky shape that's going, hopefully since it's positive, it'll be up, all right? So I'm going to pause it right now. I want you to take a look at that. That's on the screen, all right? We're taking a look at that snake-shaped graph. Okay, it appears to come up. Now, Greg, you had said it should cross 3 times. How many do you see? What does that mean? What do we see? What's happening? Oh, there's a bounce, okay? So a bounce counts as multiplicity 2, so that actually counts for 2 of them, and then one of the other ones, right? Okay. All right, so I've sort of sketched what that looks like. From your graph, could you give me a ballpark idea of maybe where that crosses right there? Does it look like 4? 3, 2? Looks like 2. All right, now I'm going to teach you how to confirm that it is for sure 2. All right, if I do this, what thinkest thou? Okay. Little synthetic, all right? So what we're going to do is take the 6 and the negative 19 and the 16 and the negative 4, and we're going to try 2. And we're going to see what the result is. We think it's crossing at 2. Let's check it out. So drop a 6, carry a 12, drop a negative 17, carry a negative 14, drop a 2, and lo and behold, we get 0. Okay? 0 is indeed, when the remainder is 0, that means that the 2 is actually a 0 or a perfect x-intercept. Now what about the other ones? Okay, where do you think it's bouncing off of? A half? All right, let me show you what to do with the second one. Okay, Ella thinks that it's crossing at half, so we're going to check it out. We're going to do synthetic division again. we're not going to go back to the beginning numbers of 6, negative 19, 16, and negative 4. We're going to go from where we're at. There's no point in going back and redoing what we just did with different, because then you're just going to end up in a never-ending cycle. We want to make progress. So we're going to use these new numbers of 6 and negative 7 and 2. So we're going to drop the 6, which means we carry a 3. We drop a negative 4, which means we carry a negative 2, and we get 0 again. Which means, yep, 1/2 was a place where this touched the x-axis. Okay, but there's got to be 3 of them. There have to be 3 because the degree was 3. You think it's a half again? Okay, well, we'll try it. Because we think maybe there's multiplicity going on. We think maybe, okay, it's bouncing. Let's check. Let's drop the 6. Which gives me a 6, carry a 3. That gives me a negative 1. That gives me a negative half. That gives me a negative half. Gives me a negative fourth. Gives me a negative 1/4. Uh-oh.
It's not.
It didn't come out with 0. Crud. Shoot. That means it's not really bouncing there. Maybe it looks like it's bouncing to my eyes, but it means it's not bouncing. So shoot, that didn't work. Okay. I have the luxury of having an eraser, so I'm going to take, well, half didn't work, so I got to get rid of all these things that didn't, because it did not turn out to be 0. Did not choose wisely. Okay, so how can I figure out this last one? Do I just keep randomly guessing? Okay, and the answer is no. There's definitely not a purpose in keeping on randomly guessing. What we're going to do is reattach the variables. So let's watch how our variables changed. When I started this process, what variable was up here on the 6? A cube. Okay, when it worked the first time, now what's the variable on there? A square. And then it worked the second time, and now I have an x, a 6x. So I don't have to guess. I can take 6x minus 4 and set it equal, since all the other stuff was 0, I can set it equal to 0, and I can solve that. So how do I quick solve that? Add 4 to both sides. Divide by 6. X is 4/6, which reduces to 2/3. And that is the missing number, which means it's crossing at 2/3. Which means it wasn't really bouncing, but it was so close on my graph that I couldn't tell that by the naked eye. So what the graph is really doing, let me use my eraser one more time. Let me clean up this middle section right here. It's not really crossing just at 1/2. It's crossing at 1/2 and also crossing at 2/3. I just couldn't see it because my graph was zoomed in too close. So it's also crossing at 2/3. So let's see all 4 parts here. Let's come back to our thinking about our cycle. All 4 parts are polynomial, well, we had the polynomial for starters. We knew that. The next part of my cycle was graph, and that's what we did second. So we went from polynomial to graph. From graph, what comes next in the cycle? Zeros. Okay, and I found my zeros. I found all 3 of them. The zeros were 2 and 1/2 and 2/3. Those were my zeros. So now what's the only piece of the cycle I haven't done? Factors. Okay, and so now I need to create the factors, and there should be one factor that matches with every single 0. And so my factors are going to be x minus 2. How do I do the 1/2? 2x minus 1. And how do I do the 2/3? 3x minus 2. And those are called my factors. And if I wanted to get all the way back to the beginning and finish my cycle, how would I go from factors back to the polynomial? Superfoil. And if I superfoil, I should be back to the beginning again. Okay, we're not going to do that right now, but we could imagine that we did. All right, let's try another one. Okay, so all these pieces are coming together. All right, let's try this. Let's look at the graph of y equals plain x cubed plus x squared minus 8x minus 6. So take a look at that graph and let's see what that cubic looks like. You can only do synthetic division on the ones that you're really confident of, that you're pretty confident you know where they're crossing through. So of those three, and we knew there was being 3 because of the power 3, of those three, is there any particular one that you're pretty confident about? One? Okay, 1 would be like right here, and there's nothing crossing right there on my graph at 1. So -3, this one right here. All right, so we're feeling pretty good about -3. What about the next one that comes after -3? You think it's -1? Well, let's check them out. Okay, so we're gonna give it a shot, see what we can come up with. So we're gonna try -3. And we're going to use synthetic division. How will we know if -3 is right or not? The remainder is 0. So 1, 1, -8, -6. All right, drop the 1, carry a -3. Drop a -2, carry a 6. Drop a -2, carry a +6. We get 0. Okay, so that worked out great. Are you feeling confident enough to try another one? You thought it was -1. Now you're changing your mind and you say it's you're not confident enough anymore?
I don't know. It's like you put it in the same spot.
Let's try -1. So we'll drop it.
Maybe it's because I don't actually.
Carry a -1, that gives me -3. Carry a 3, that gives me 1. Carry a -1, I get -1. So it's not -1. All right, so do we have to just keep guessing? And the answer is no. As soon as you get down to, how many more do we have left to find? 2. As soon as you get down to the point, you will always be able to find enough to get yourself down to 2. Okay, I promise. All of the ones that they give you are designed for you to be able to figure out that they all right, but once you get down to 2, you can reattach those variables. So let's take a look at what our variables are. This 1 started with what kind of variable? A 3. Now it's down to a squared. As soon as you get down to a square, you don't have to guess anymore. So we've got 1x squared minus 2x minus 2 equals 0. And what handy-dandy tool? Star's not going to work. You can try it, but it's not going to work. Quadratic formula, yeah. No. So x equals -b, that's -2, plus or minus the square root of b again squared, minus 4 times 1 times -2, all over 2. That gives me 2 plus or minus square root 12 over 2, which you got to break up into 2 rad 3. And you got to break it up again before you start getting canceling and reducing. You've got to have 2 over 2 plus or minus 2 rad 3 over 2. Then you can reduce and you get 1 plus or minus rad 3, which you never would have guessed from the calculator. You never would have come up with that on your own. So let's go back to our cycle of where we're at. We started with the polynomial. From the polynomial, we created a graph. From the graph, we were able to come up with one zero we felt pretty confident on. That was -3. And then we came up with 2 other zeros using the quadratic formula. So 1 plus rad 3, 1 minus rad 3. From the zeros, I should be able to create one factor for each 0. So my factors are going to be x plus 3, x minus 1 plus rad 3, and x minus 1 minus rad 3. And those are my 3 factors. And if we superfoiled those 3 factors together, we would come up with the same, should come up with the same polynomial we started with. but we're not going to do that right now, thankfully.
Yeah.
Okay, I have one final example. Do you have any questions on example 2? All right, last one. Do a fourth power. Okay, y equals 2x to the 4th minus 7x to the 3rd minus 8x squared plus 14x plus 8. Just to save us time, I'm going to tell you what this drawing ends up looking like. Well, it's a degree 4. You tell me, what does it look like? Okay, it's going to be a W-ish shape. Okay, this one comes down and then back up and then back down lower and then back up again. Okay, yeah, it's not symmetric, but that's okay. Okay. All right, so we think we're pretty confident right here. He thinks -1/2. So let's give it a try and let's see how his -1/2 turns out. I promise that you'll always be able to find enough to get you down to you only having two being left. So let's try -1/2 and we'll see if we get a result of 0. 2, -7, -8, 14, and 8. So drop the 2, carry a -1. Drop a -8, carry a 4. Drop a -4, carry a -2. No, +2, 16, -8. Good job, Greg. Okay, he came up with 0, and that is correct. All right, is anybody else looking at the graph and feel confident about another one? I'll tell you this one right here is 4. We'll give that a try. So we'll try 4. And again, don't start over. Go with what the numbers you have. So carry a 2, drop an 8, or drop a 2, carry an 8, get a 0. 0, we get a -4, -16, 0. All right, yeah.
So basically, until you get to x squared, do you kind of have to guess?
Not guess, but using an educated guess off of where it's crossing the x-axis. Okay, ones that look like it's crossing at whole numbers or at least decent decimals, like half or something like that. Okay, so it's an educated guess, but it should be a pretty solid one. So at this point, we want to reattach the variables. So we see that we were starting with x to the 4th. That brings it down to x cubed. So now we're at x squared. So what we've gotten ourselves to is 2x squared plus 0x minus 4 equals 0. We can use the quadratic formula to solve this. We also realize that we don't have to use the quadratic formula in situations where the middle term is 0. We can just add 4 to both sides and then divide by 2 and then apply the square root. But what we'd have to remember is always that you have a plus or minus square root of 2. So if we look at our cycle now, where we started with the polynomial, we created a graph. From the graph, we were able to get some of our zeros, specifically -1/2 and 4. And then we were able to get 2 and -2, which then leads us to being able to develop factors. And so just in writing them all out, our factors would be 2x plus 1, x minus 4, x minus the square root of 2, and x plus the square root of 2. If we would FOIL and superFOIL all of those factors out, we should be back to the polynomial that we started with.